All right, Econ friends, welcome back. In our previous video, we had introduced the idea of elasticity as a measure of responsiveness, and we learned how to calculate it, how to compute it, and then we learned about the continuum and the ways to kind of classify goods. I also had started that lecture, that video, with a little bit of a riddle, which was if you are a publisher and your agent says they're raising the price of your books from $25 to $30, are you happy about this? Are you upset by this? Now, with the grasp of elasticity, we can figure that out. In this video, what we're going to do is wrap up our discussion of price elasticity of demand by getting a few of its applications and then talking about the determinants. That is the factors or the criteria that would lead one good to be more elastic or more inelastic. So let's jump in. One of the first ways that you can utilize this knowledge, and this is really important for business owners, for example, is when we take a look at the connection between price elasticity and total expenditure. Let's take a look at panel A. Let's contrast it with panel B, okay? Let's note, first of all, that here in panel A, we're going to say that this demand curve that you see that it's flatter, that this is a relatively elastic demand curve. And we're going to argue that over here in panel B, steeper, this is going to be a relatively inelastic demand curve, okay? Let's go back to our question from the first video and apply it now with this example. Look at panel A. Suppose that we start at a price of $9. Note that at a price of $9, we go across, we hit it, we go down. At $9, 120 units are sold. Therefore, at a price of $9, total revenue, meaning the receipts that you're going to get, are going to be equal to $1,080. That's $9 per item sold, selling 120 items. Now let's say that the price goes up and it's now $11. So the price has gone from 9 up to 11. At a price of $11, we go over, we hit the demand curve, we go down, and we see that we have 80. So at a price equal to 11, the quantity demanded is 80. And our total revenue is going to be 11 times 80, which is going to be $880. And you'll notice then that in this case, as the price went up, the total revenues went down. Now let's jump over to panel B and see if the same thing occurred or something different occurred. In panel B, the price again started at $9. You go over and you had at $9, 101 units sold. So at a price equal to 9, QD was 101, and therefore total revenue was going to be $909. Now, price goes up again from $9 to $11. At $11, we go over, we go down, and look at that. At a price of $11, the quantity demanded is 99. You know, both from the definition of inelastic and from these numbers, that clearly the customers in this market are not all that price sensitive. The price went up by a pretty decent amount and they only lost 2 customers. It's a small percentage, right? Think back to your definitions. If you do the total revenues, you're going to see that it's 11 times 99, $1,089. And therefore, we can conclude something. If you know whether your curve is elastic or inelastic, then you can make a prediction of how the price change under price elasticity will affect total expenditure. Here's another way to think about it. Let's go back to blue. If a good is elastic, we know that a price increase will lead to a really, really significant, a very responsive drop in quantity demanded, right? That's just the definition. Since total revenue is equal to P times Q, and Q falls by a lot more than P goes up, total revenue will fall. So for an elastic good, we would say that the prices, the total revenues, move in the opposite direction. Because if prices go in one direction, that is more than offset by a drop in sales, by a drop in consumption, and therefore your revenues go the opposite way. Now, let's take a look at an inelastic good. We know that by definition, with an inelastic good, price can go up a lot, and you're still barely going to lose any customers, because by definition, inelastic goods are not price sensitive, right? So if we say that total revenue is equal to P times Q, if the price goes up, Q will go down, but not that much, and therefore total revenue will go up. And therefore we would argue that for inelastic items, prices and total revenues go in the same direction. You can think it through logically. You can do it by simply doing the arrows with the P and the QD, or you could even take a look here in an actual example with the real demand curve at the impact of a price change on total revenue, okay? So we're going to conclude with this. Price increases will increase total revenue when demand is price inelastic, and will decrease total revenue when demand is price elastic. On the other hand, a price decrease will increase total revenue when demand is price elastic, and it will decrease total revenue when the demand is inelastic. Simplest way to think about it, P and TR go in the same direction when it's inelastic. They go in opposite directions when it's elastic. So that's one application. Another application is price elasticity along a linear demand curve, which is simply saying if you have a straight demand curve, a straight line demand curve, how is elasticity changing over the course of that curve? One thing to bear in mind, even though for a straight line demand curve, the slope is going to be constant, elasticity will not be constant. So along a straight demand curve, elasticity will change at different points on the curve. Let's look into it a little bit deeper. So again, even though the slope of a linear demand curve is constant, the price elasticity will vary. On a linear demand curve, what we believe and what we can show mathematically is that the top half of the demand curve is elastic, while the bottom half is inelastic. And we can conclude that generally higher prices will lead to higher elasticity of demand. You can take a look and see it right here. I've given you a demand schedule here in panel A. You see that we have points A, B, C, D, and E with the associated P and Q, and we plotted those right here on this demand curve. You can see it right there. Well, take a look. Note that from A to B, as price goes down, total revenue goes up. Again, total revenue, P times Q, so we simply multiplied 8 by 2 and got 16. So as we move from A to B, as the price went down, the total revenue went up. And that's elastic. We just described that. Look at the move from B to C. Prices are going down, total revenues are going up. Also elastic, but total revenues went up by a little bit less, so it's less elastic. And as we continue to go down the curve, C to D, prices go down, Total revenue goes down, same direction, inelastic. And from D to E, prices are again going down. Total revenue is again going down by more, same direction, inelastic, and we would say more inelastic. So we can summarize this by taking a look, price elasticity along a linear demand curve. And the basic idea is that the top half of the curve, here shown by points A through C, are going to be elastic. The bottom half of the curve, here from point C to D, is going to be inelastic. And you will note that mathematically, the break point between the elastic region and the inelastic region occurs at the point where the demand curve is unit elastic. You would also, if you were to take a look up here, and if you knew a little bit about marginal and some of the first derivative functions in business calculus, you would see that total revenue is maximized at point C, which is the unit elastic point. Down here in panel C, this red graph is plotting total revenue against quantity. Total revenue against quantity. And you can see that at a quantity of 5 sold, total revenue is maximized. For those of you who've had some business calc and understand first order derivatives, this will make some sense to you. If you haven't had it, that's okay too. You don't need it, but I wanted to make that reference. Okay. Finally, just know that while the unit elastic point is the point at which total revenues are maximized, just be aware, to be very clear, that the firm's goal is not to maximize total revenues. The goal is to maximize profits. You got to be careful about that. Okay. Finally, now that we understand some of the applications of price elasticity of demand, we have to ask the question, what makes one good elastic and another good inelastic? And we can offer a handful of criteria, which we will call determinants, that will show it to us. Determinant number 1, the availability of substitutes. The basic idea here is the more substitutes exist for an item, the more elastic it is. That's why, for example, we said way up here that the perfectly elastic item would be some random farmer's wheat. Since wheat is a commodity, and since most farmers' wheat is pretty equal, there's pretty much infinite substitutes for one farmer's wheat. Lots of substitutes, more elastic. The second criteria is what we would call the definition of the market. There's lots of ways to define a market. You could define a market broadly by calling the market for food, or the market for Italian food, or the market for pizza, or the market for thin crust pizza. So you can define a market broadly or narrowly. What we believe is that the more narrowly you define the market, okay, the more narrow that you define the market, the more subs there are for the good, and therefore the more elastic it is. Food as a general category, there's not many substitutes for food if you want to stay alive. There's substitutes for Italian food. There's lots of subs for pizza. There's lots and lots of subs for thin crust pizza. So the more narrow you get with your definition, the more subs you have, the more elastic you have. The third category, the third determinant, the third criteria, the amount of time that you have to adjust. Since the more time you have, the more subs you can find, we believe that longer time frames lead to more elastic demands. Shorter time frames lead to more inelastic demands. Think about an airline flight, or at least a pre-COVID airline flight. If you knew that you wanted to take a flight sometime in the future, 2, 3, 4 months from now, you'd have lots of time to search different airlines, price things out, and you'd probably get a lower price. If you realize, uh-oh, I have to fly somewhere tomorrow morning, you don't have any time. And the airline's probably going to stick you with a higher price because they know that you don't have time to find substitutes, and therefore it's going to be more inelastic, and you're going to have to bite the bullet and pay that higher price. Okay. The fourth, the share of budget. Basically, what we believe is that the demand for more expensive items will tend to be more price elastic because they take up a bigger chunk of your budget. Imagine that the price of a candy bar doubles and the price of a house doubles. The prices of both doubled. They both went up by 100%, but a candy bar is a small part of your budget. So it's not going to be a real big deal. You're not going to really react strongly either way, probably very inelastic. But if the price of a house doubles, or if the price of your rent doubles, that's going to cost you thousands of extra dollars a month. And that's going to have an impact on you. And you're going to be much more critical and much more responsive to that price change. So again, for share of budget, we believe that the more expensive an item is, the more price elastic it will be. Another criteria, the fifth one, would be the breakdown of necessities and luxuries and addictive goods. We believe that necessities will be more inelastic. If you really need something, you have to have it to survive. You'll have to pay the price that they're charging. You may complain about it, but you're going to have to pay it. So we believe that necessities are going to be, you're going to be less responsive to price changes, and therefore necessities will be classified as more inelastic. Luxury goods, on the other hand, you can sort of do without. They might be nice to have, you might really crave one, but you don't need it. And especially because many luxury goods tend to be expensive, take up a larger share of your budget, luxury goods will be more elastic. Finally, addictive goods tend to be highly inelastic. And you can imagine the nature of an addictive good is such that you need it. And you're going to have to pay whatever price you need because you really can't control your consumption because you're addicted by definition. Okay, so the fifth criteria, necessities, luxuries, and if a product is addictive. And the final, and this is something that those of you guys who are business majors, especially you marketing majors, will be tied to in your future studies. The sixth criteria, the sixth determinant of elasticity would be things like advertising and brand loyalty. And what we believe in economics, and really more in the realm of business and marketing, MBA stuff, is that successful advertisement, successful ads will lead to more brand loyalty. If a company can craft a really good ad and get you to really like that product, you're building brand loyalty with that product. Companies want you to have brand loyalty because if you have brand loyalty to one product, you're not going to be as easily swayed by substitutes. If you really, really, really prefer Coca-Cola over Pepsi, you're not going to see Pepsi as a real sub for Coke. You're going to be more loyal to Coke, and because there's less perceived substitutes, Coca-Cola will be to you relatively more inelastic, and that will give Coca-Cola a little degree of pricing power over you. Okay, so we believe that successful ads will increase brand loyalty. This will lead to a lower perception of substitutes, and this in turn will lead to demand becoming more inelastic. And of course, from a business perspective, as we learned in the total revenue section, if a company knows that you are more inelastic to their product, they can probably charge you a little bit more, build some market power, and earn some profits. Okay? So my friends, we're now done with the price elasticity of demand. You're familiar now with some applications and with 6 criteria that can help you decide if a product is more elastic or more inelastic. Next time we connect, we'll talk about another metric, the price elasticity of supply. I'll talk to you soon. Thank you.